Okay, hello everyone. In a new video, so we have reached part 5 of chapter 6, which is the chapter of AC voltage and the second unit of electricity. And in this one we are going to complete solving exercises. Then we have reached exercise 11. An electric water heater that can be considered as a resistor of resistance R is equal to 45.2 ohms. Then the value of R here is given by R is equal to 45.2 ohms is fed by the voltage U of the mains. Then document 1 shows the waveform of U takes square root of 2 is equal to 1.415. Now, since they mentioned document 1, now we can use it. And let's recall that the trick in solving such type of exercises is to label the values of X and Y on the given document as well as SV and VB. So first let's start by X, and usually X is calculated by considering two consecutive peaks. In this case we don't have two peaks, so then we can count from the center. Then let's choose a point, skip a point and choose another point. In this case we have 1 2 3 4 5 6 7 8 9 10. So the value of X is equal to 10 divisions. And as for the value of Y, now we count Y from the center to the maximum point reached from the curve. So we have 1 2. Now this is not clear if it is 3 or 3.2, but if you consider the dotted line, it is exactly on 3.2. And on your notes you can use a ruler. Okay, so using a ruler, then the reading will be more accurate. Now if we proceed for the values of SV and VB, now SV is the scale along the vertical axis. Here we have 100 volts per division. This is the y-axis, which is the vertical. Then SV is equal to 100 volts per division. As for VB, it is the scale along the x-axis, which is given by 2 milliseconds for each one division, which is equal to, now we know that millisecond is not the SI unit of time. In order to convert from milliseconds to seconds, we divide by 1000. So this is equal to 0.002 seconds per division. And by this, now we are ready to solve the exercise. Now in number 1, they are telling me name the type of the voltage U. And by name, so no need to explain, but here in this case I will explain, which is better. So always better to explain. Now first of all, it varies with time, because we know that always graphs in physics are labeled by, the axes are labeled by physical quantities. So this is labeled by T, this is labeled by U. So it is varying with respect to time. Let me say since. So part of the curve is positive, this is positive, and part of the curve is what? Negative. Since it varies with time, and alternately positive and negative, moreover, the shape of the curve is given by sinusoidal. The shape of this curve is given by sinusoidal. Then it is AC sinusoidal voltage source. Now in number 2.1, they are telling me, referring to document 1, determine the maximum value UM of U. Then UM is given by SV multiplied by Y. The value of SV is given by 100 volts per division. And the value of Y in this case is given by 3.2. Plugging this on the calculator, then the value of UM is given by 320. Since both SV and Y are expressed in SI, so the value of UM will be expressed in SI, which is volts. Then in this case, UM is equal to 320 volts. Now as for 2.2, we are interested in determining the period T, which is given by VB multiplied by X. Now the value of VB is given by 0.002 and the value of X is given by 10. So in this case the period is given by 0.02 seconds. Why seconds? Because VB and X are expressed in the SI, so the value of the period will be expressed in the SI, which is seconds. Now after we have determined UM and the period, we expect that they will ask us about the frequency and the effective voltage, and indeed in 3.1 they are telling me deduce the effective voltage, and by deduce it means that we notice the previous parts. In the previous part we have determined UM, and we know that U effective is equal to UM divided by square root of 2. Now the value of UM is given by 320 and the square root of 2 is given by this. We use the numerical value of the square root of 2 and not using the calculator. Now we plug this fraction on the calculator and it's given by 226.15. Since UM is expressed in the SI, which is volts, then U effective will be expressed in the SI, which is volts. Now in 3.2 they are telling us to deduce the frequency f of u, and the frequency is related to the period. For this reason they have stated deduce, which is given by 1 of the period. Now the period is given by 0.02. Plugging this fraction on the calculator, and the value of f is given by 50. Since the period is expressed in the SI, so the value of f will be expressed in the SI, which is hertz. So f is equal to 50 hertz. Let me make some space. Now number 4, they are telling me the water heater is used at the rate of 6 hours per day. So we have that T is equal to 6 hours. So what does this time represent? This time represent the number of hours in which this water heater is used per day. Now in 4.1 they are telling me determine the effective value I of the current I through R. So we know that there are several ways to determine the value of I. So for example, one of them is using the law of addition of currents, but here we don't have an electric circuit, so we are left with P is equal to U multiplied by I, or Ohm's law, for example, U is equal to R multiplied by I. And in this case, because we have the value of R and we have determined the value of U effective, which is given by 226.15 volts, then we can determine the value of I, because according to Ohm's law, apply Ohm's law to the water heater. U is equal to R multiplied by I, and we are interested in determining the value of I. Then constructing the triangle of this formula here, because we have multiply, then U will be at the top, R and I at the bottom. We are interested in determining the value of I. Then the value of I is given by U divided by R. Here the effective current is labeled by I, whereas the effective voltage is labeled by U effective, which is equal to 226.15 divided by the value of R, which is given 45.2. Now plugging this fraction on the calculator, then the value of I is given by 5. Since both U and R are expressed in the SI, so the value of I will be expressed in the SI, which is amperes. then I is equal to 5 amperes. What does this current represent? The effective current related to U effective via the value of R according to Ohm's law. Now in 4.2 they are telling me determine in kilowatt the electric power consumed by the water heater. So first we need to determine the value of the electric power P. We don't have the value of the electric power. So the power is by definition U multiplied by I. So this is U effective corresponding for I effective. Now the value of U is given by 226.15 multiplied by 5. Plugging this on the calculator, then the value of P is given by 1130.75. Since both U and I are expressed in the SI, so the value of P will be in the SI, which is watts. But here we are interested in determining the electric power consumed by the water heater in kilowatts. So we must convert this value to kilowatts. So P, which is equal to 1130.75 watts, is equal to 1130.75 divided by 1000. So this is equal to 1.13 kilowatts. So the value of P is given by 1.13 kilowatts. And here, because we have determined the value of P in kilowatts and we already have the value of T of hours, then it seems that we are interested in determining the electric bill. So let me here write on the scratch the different steps that we usually follow in order to determine the electric bill. Then step number 1 is to convert P to the kilowatts. Step number 2 is to calculate E1 for 1 day. Step number 3 is to calculate E for 1 month. And step 4 is to calculate the cost or the price. Okay. So recall that I'm writing these steps on the scratch and they are not considered as part of the answer. Now we have reached 4.2. Sorry, 4.3. In 4.3 they are telling me calculate in kilowatt hour the electric energy. The formula of the electric energy in general is given by E is equal to P times C. So always in physics we need to start by writing the corresponding formula, and this usually they give it half a mark. Consumed by the water heater in 1 day. So in 1 day, we know that in 1 day we have T is equal to 6 hours. But notice that here the unit of energy is given by kilowatt hours. So for this reason P must be expressed in kilowatts and T must be expressed in hours. The value of P is given by 1.13 and the value of T is given by 6. This is E1, so plugging this on the calculator, then the value of E1 is given by 6.78. Since this is expressed in kilowatts and this is an hour, then the value of E1 will be kilowatts hour. So E1 is equal to 6.78 kilowatts hour. So what does this energy represent? This is the energy E1 consumed by this water heater functioning 6 hours per day under an effective voltage 220. Now in 4.4, in this case we are done with the step number 1 and step number 2. In 4.4, we need to determine the monthly cost to be paid by the consuming using this water heater, knowing that the average price of 1 kilowatt hour is 100 Lebanese liras, take 1 month is equal to 30 days. Now, in order to proceed with 4.4, which is the last step, which is the cost, first we need to do step 3, which is E for 1 month, which is the monthly consumption. In this case, the monthly consumption is given by E1 times the number of days, which is equal to 6.78 multiplied by the number of days. They are telling me take 1 month is equal to 30 days. Now plugging this on the calculator, then the value of the electric energy is given by 203.4 kilowatts hour. But remember that we are interested in determining the monthly cost, which corresponds for E times the price, which is equal to 203.4 multiplied by 100, which is equal to 20,340 Lebanese liras. So this is the cost to be paid upon the usage of this water heater for at a rate of 6 hours per day for 30 days in a month. Now let's move to the next exercise, which is exercise number 12. In this exercise, they are telling us the two waveforms 1 and 2 of documents 1 and 2. They mentioned documents 1 and 2, now we can use them. Represents the electric voltage UAB and UCD respectively. Then this is UAB and this is UCD. And hereby respectively they mean UAB corresponds for 1, which is this, and UCD corresponds for 2, which is this. Okay, in the absence of any voltage, the horizontal line passes through the center of the screen of the oscilloscope, and this is important in order for the reading of the oscilloscope to be accurate. Now, the vertical sensitivity on both the channels is given by SV is equal to 5 volts per division. So this value is the same for both this and this one, okay? Now 1.1. Now exploitation of the waveform of document 1. So we are discussing document 1. They are telling me give the type of the voltage UAB represented by the waveform 1, justify. So whenever they ask us about the type, we need to say whether it's AC or DC. Notice that in this case, in document 1, we have a luminous line, a horizontal luminous line, which is constant with respect to time, which means it is a DC voltage. So it is constant with time, and is represented by a horizontal luminous line. So why it is constant with respect to time? Because this is time, this is the value of U. For all times, the value of the voltage is constant and takes this value, which can be read here from this axis. And it is represented by a luminous line, then it is a DC voltage source. So whenever they ask us why it is a DC, or if we have this shape of the curve and they are asking me about the justification of the type of the voltage, we can always refer to this answer. And here no need to discuss whether it's negative or positive, because the sign will be discussed in 1.2. Now in 1.2 they are telling us the value of this voltage is negative Y. So we know that the sign of the voltage is positive or negative depending whether the luminous line is displaced upward or downward. So notice that in this case the luminous line is displaced downward. Then the measured voltage, then the value of this voltage is negative. Now as for 1.3, they are telling me determine the voltage UAB. So always the trick in solving such type of exercises also is to determine the values of x and y before we proceed. So as for this one, let's determine the value of y. So y is equal to minus, and it's displaced downward by 1, 2. Notice that the luminous line coincides with the second division, knowing that each subdivision corresponds to 0.2. So it is given by minus 2.4 divisions. Now here, recall that in the case of DC voltage, the value of x is undefined. As for the AC voltage, x is the number of divisions between two consecutive peaks, and in this case is given by 1, 2, 3, and 4. As for the value of y in this case, y is always positive and it's given by 1, 2. Now if we consider the ruler and we project this point along the y-axis, so it is along 2.4 divisions. Using the ruler on your notebooks, the reading will be more accurate. Now referring back to determine the value of UAB for the voltage of document 1, which is given by SV multiplied by Y. Now the value of SV is common to be 5. And the value of Y is given by minus 2.4. Plugging this on the calculator, then the value of UAB is given by minus 12. Since both SV and Y are expressed in the SI, so the value of U will be in the SI, which is volts. Now in 1.4, they are telling me, is the phase of the oscilloscope connected to the point A or to B? Y. Now notice that the oscilloscope is measuring UAB. And we know that always the first letter corresponds to the phase terminal. Then the phase terminal is connected to A. Okay. And the mass terminal is connected to B, but here we are only interested in mentioning the phase terminal. Now in 1.5, we need to give the name of a source tension that may deliver such voltage, which is DC voltage, and we know that the most common one is a battery. We can also say, for example, dry cell, galvanic cell, etc. All of these are valid examples of DC voltage source. Now in number 2, they are telling me exploitation of the waveform of document 2. Say they mentioned document 2, now we are talking about it. In 2.1, give the type of the voltage UCD represented by the waveform 2. So let me say, since it varies with time, and is alternately positive and negative. So what does this mean? So this is the time axis and this is the voltage U. So notice that it is changing with time, it is varying, and part of it is positive and the other part is negative, and the shape is given by sinusoidal. For this reason then, it is AC sinusoidal voltage source. Now in 2.2, we need to determine the maximum value of UCD, which is given by UM. is equal to SV multiplied by Y. The value of SV is given by 5 and its Y is given by 2.4. Plugging this on the calculator, the new M is given by 12 volts. Y volts, because both SV and Y are expressed in the SI, so the value of UM will be in the SI, which is volts. Now in number 3 they are telling me, in the same part they are telling me to deduce the effective value of UCD. So U effective we can be deduced from UM because it's given by UM divided by radical 2. Now in this case the value of UM is given by 12. So notice that previously they didn't give us a value of radical 2, so we keep it as it is. Now we plug this on the calculator, then the value of U effective is given by 8.49 volts. Then U effective is given by 8.49 volts. And let me write down here that UAB is equal to minus 12 volts, in which here UM is equal to 12 volts and U effective is given by 8.49 volts. Now in number 3 they are telling me consider a lamp L labeled by 12 volts, so this 12 volt represent the indication. In 3.1 what does the indication 12 volts represent? We know that it is the rated voltage of the lamp L under which it functions normally. Okay, so it is the voltage because it carries the unit volts. Now in 3.2 they are telling me L functions normally under the voltage UABY. Okay, so now referring to this question, we know that the answer will be because since the applied voltage is equal to the rated voltage. But let's explain more referring to the values. So we have two voltage sources. This is UAB, which is given by minus 12 volts. As for UCD, we have two voltages. We have UM 12 volt and U effective 8.49 volts. Out of these two, we must consider U effective because it is the one that makes the effect, and we must eliminate this. Now, although here that UAB is given by minus, but the minus sign can be ignored because the voltage simply can be measured from B to A, and this is given by 12 volts. So what does this means? That we have just only reversed the terminals of the voltage source. Now considering both voltages, this is 12 volts and this is 8.49, both of them are applied voltages. Comparing them with the rated voltage, we can notice that the only one that is equal to the 12 is the value of UAB. And let me repeat that the thing related to the minus sign is not important, because if we are measuring UAB, this measurement can be reversed by reversing the terminals and it's equal to 12 volts. So what's important, the number, and we don't care much about the sign. So now this is on one hand. On the other hand, looking at the question, one can directly know that the answer of this question would be, since the applied voltage is equal to the rated voltage of the lamp L, which means that 12 volts is equal to 12 volts, then the lamp L will function normally. Okay. Now as for the final part of this exercise in 3.3, They are telling me L doesn't function normally under the voltage UCD. So now the voltage UCD is represented by two voltages UM and U effective, but we will consider U effective because it is the one that's making the effect. Notice that this applied voltage is less than the rated voltage. So 8.49 volts is less than 12 volts. Then the lamp L will not function or function weakly, which reflects the case that L doesn't function normally. Doesn't function normally means two things, that it will either not function or function weakly. So that's it for exercise number 12. Let's move to the final exercise, which is exercise number 13. Now in this exercise, they are telling me document 1 represents the waveform of the voltage U. So they are talking about document 1. Now we can ignore document 2 for the moment. The oscilloscope is adjusted as follow. Now, okay, the horizontal sensitivity, which is the time base, is given by VB is equal to 5 milliseconds per division, and the vertical sensitivity is given by 10 volts per division. Now VB here is not given in the SI, so in order to convert from milliseconds to seconds, we simply divide by 1000. Then 5 divided by 1000, then the value of VB is given by 0.005 seconds per division. Now, and let me repeat that the trick in solving such type of exercises is to indicate the values of x and y on the graph before we proceed, because this is a curve, and a curve is always represented by a point which is given by x and y. Okay. Now let's determine the values of x and y. Let's start by x. X cannot be counted from two consecutive peaks because they don't exist. Now choosing a point, skipping a point, choosing another point, counting these. So the dots are given by 8. And as for the value of y, notice that the curve exactly passes through this line, which corresponds to 1, 2, 3 divisions. Now we are ready to solve the problem. Now in 1.1 they are telling me indicate the type of the voltage U. So indicate, it means that we need to state with the justification. Notice that since it varies with time, so always axes in physics are labeled by physical quantity. This is T and this is U. It is varying with time changing, and it is alternately positive, and in these parts are negative with time, and is alternately positive and negative. And notice that the shape of this curve is given by sinusoidal. Then it is AC sinusoidal voltage source. Okay, so this is it for 1.1. Now in 1.2 they are telling me calculate the period and the frequency of U. So let's start by the period. The period is given by VB multiplied by X. Now the value of VB in the SI is given by 0.005 multiplied by the value of X, which is given by 8, and eventually plugging this on the calculator, then the value of the period is given by 0.04 seconds. So the period is given by 0.04 seconds. Now the frequency can be directly deduced from the period because f is equal to 1 of the period, so which is equal to 1 divided by 0.04. Plugging this on the calculator, then the value of the frequency is given by 25. Since the period is expressed in the SI, which is seconds, then the value of f will be in the SI, which is hertz. So f is equal to 25 hertz. Now in 1.3, they are telling me calculate the maximum value of U. So UM is basically calculated via the following formula. Now the value of SV is given by 10. And the value of Y is given by 3. Plugging this on the calculator, then the value of UM is given by 30. Since both SV and Y are expressed in the SI, so the value of UM will be in the SI, which is volts. So this is it for part 1 of this exercise. Now part 2, they are telling me the generator G still delivers the same voltage. Sorry, we didn't deduce the effective voltage. Okay. So now they are telling me to deduce its effective voltage. So U effective can be deduced from UM because it's given by UM divided by radical 2. Now the value of UM is given by 30 divided by radical 2. Notice that the numerical value of radical 2 is not given, or the decimal value. Now plugging this on the calculator, so the value of UM is given by, U effective is given by 21.21 volts. Okay. So U effective and let me here write down the values. So we have that the period, okay, without writing them down. Now in part 2, they are telling me the generator G still delivers the same voltage U. We modify one of the two sensitivities of the oscilloscope. The waveform of document 2 is then obtained. So they mentioned document 2, now we can use it. And let's reread the question carefully, or the given carefully. They are telling me we modify, and the word modify means changes one of the two sensitivities. The two sensitivities are given by VB and SV. So when they say they modified, so either one of these, either SV or VB has been changed. For example, SV could have been changed to 8 volts per division. Okay, we don't know. Now in 2.1, okay, indicate with a justification which of the two sensitivities VB or SV has been modified, which means has been changed. So before answering this question, as we have said previously, is that the trick in solving such type of exercises is to write the values of X and Y. So notice that in this case the value of X corresponding to two consecutive peaks is given by 1, 2, 3, 4. And the value of Y, which is the number of divisions from the center to the maximum point reached by the curve, which is 3 divisions. Now notice that here in this case we didn't place the values of SV and VB because they already told me that one of them has changed. So we don't know whether SV or VB has been changed. For this reason I didn't write here anything. Now they are telling me indicate by itself. It means that we need to justify which of the two sensitivities VB or SV has been modified. Now if we look carefully here between the values, we notice that the formulas of relating SV and VB, we know that the period is given by VB multiplied by X, and we know that is equal to SV multiplied by Y. So taking into consideration both these two formulas, and notice that Y remained 3 divisions, but the value of X changes from 8 to 4 because X changes and the value of X is related to VB, which means that VB has been changed. Okay, so I repeat, notice that if you compare both values, Y remains the same, which is 3, whereas X changes from 8 to 4. And recall that X is related to VB because T is equal to VB multiplied by X. Since X changes, then VB will change accordingly. So let me write down, since the value of X has changed, then VB has been modified. Okay. So now in 2.2 they are telling me calculate the new value of the sensitivity, because now we know that the sensitivity is VB. So the period is given by VB multiplied by X, and we are interested in determining VB. Constructing the triangle of this formula here, because we have multiplied, and the period will be at the top, VB and X at the bottom, we are interested in determining the value of VB. So VB is equal to the period divided by X. Now notice that the period didn't change, which is given by 0.04. Now because I have used the period, let me erase everything to make some space. Now as for the value of X, we will use the new value of X, which is given by 4. Plugging this on the calculator, then the value of VB is given by 0.01. Because the period and the X are expressed in the SI, so the unit of VB will be in the SI, which is given by seconds per division. So VB is equal to 0.01 seconds per division. Finally, the last part, which is the part 3, we turn off the sweeping. Before we continue, what is the sweeping? The sweeping is the motion of this curve. So which is the thing responsible for the shape of the curve to be sinusoidal. So whenever we stop the sweeping, the curve will not move anymore. Okay, so they are asking me what will be the shape of the displaced voltage. We know that if the sweeping is off, this will not move anymore, but it will remain to change from positive to negative, like this, but without moving from left to right. In this segment, in this case, we observe a luminous segment along the vertical axis between a plus Y and minus Y. And by this we have finished solving this exercise. So that's it for me in this video, guys. See you soon in a new one.